Okay, today we're gonna review the temperature sensor on TinkerCad. First of all, what does the temperature sensor does? The temperature sensor, as its name implies, measures temperature. We can use it as any other component we have seen so far, connect it to the protoboard, and then read the values that it provides us, in this case of the temperature it is reading, into the Arduino, and we can work with it. Okay, so as you can see here, I have already prepared a circuit with my temperature sensor, this little black piece over here, and a LED. The idea of this circuit is that when the temperature sensor reaches out a specific temperature, or or any other temperature that is higher than that, the LED will turn on. Okay, so first of all, as any other component, we go to the right part of our workspace in TinkerCad and we can search for the component. In this case, my TinkerCad is in Spanish, but if I search temperature, you will see here that it says sensor de temperatura in Spanish, or temperature sensor if you are in English. You only have to drag your component and place it anywhere you want in your protoboard. Okay, as you can see here, the component has three letters, T, M, and P, that is the little acronym for its name, temperature sensor. So the sensor has three pins. If we move or hover our cursor over the pins, we can see what each pin does. So for example, we can see here that the first pin is for power, so it will be connected to the 5-volt line of the Arduino. The second one is a little more confusing, as it is called boot, but the boot pin will be the one connected to the Arduino, specifically to an analog Arduino pin. Remember that the analog pins are the ones that have names as A0, A1, A2, and are in the lower part of the Arduino. And the third pin is the ground pin that you connect it to the ground line as usual. Okay, so I will demonstrate my circuit over here. As you can see, the first pin goes to the 5 volts, as you can see down here. The third pin goes to the ground, and the middle pin, the one that will be reading the signal, will be connected to the analog pin A0. Remember, all these pins are analog, the ones up here are digital. So what my sensor will do is, I start the simulation, and to work with my sensor I need to click it. It will show me this little bar. It's a little hard to see because it's white, as the numbers are white as the protoboard, but as you can see here, I can drag this little ball that will change the temperature that the sensor is reading. So for example, right now I am in 15 degrees Celsius. If I increase it over around 30, my LED will turn on. Okay, so if I decrease it again, my LED will turn off. So the logic of this circuit is that when we reach out certain temperature that we will see in a moment in our code, then the LED will turn on. If the temperature is higher than that, the LED turn on. If the temperature is lower than that, it will turn off. Okay, in real life you will not have this little ball to drag the temperature out, but rather it will be measuring the real temperature of the place it is located at. Okay, it's a very simple connection. The LED is connected to a digital pin, as we have seen so far, and the TMP sensor, or temperature sensor, is connected to an analog line. Okay, so if we go to our code, we will see here that we have, first of all, I am creating five numerical variables. The first one is called red. Red will store the number 9, as it is the pin number the LED is connected to. The second variable is called TMP sensor, and it will store also the number of the pin, but in this case, as the number has a letter, well, the name of the pin has a letter, the pin will be A0. The third, fourth, and fifth one will store my temperature. So it will call it Celsius because it will store the temperature in Celsius. The fourth one will store the temperature in Fahrenheit, and the fifth one will store my base temperature, or a point of reference to turn on and off my LED. Okay, so in the void setup part, as usual, we configure our pins. The A0 is a sensor. It provides us with information. We read information from it, so it will be an input. Meanwhile, the LED will be an output because we will be sending out the signal to the LED to turn on. Now, we will review a new thing we haven't worked with. Maybe some of you already know it. It's called serial begin. Serial begin helps us work or see numerical and text data in the Arduino. What do I mean by that? If you go down here where it says serial monitor or monitoring serial, if you have it in English or Spanish, and you extend that part, you will see that when you can send something to be printed as a text, so you can, for example, have the numerical values that the sensor is measuring in real time, for example. So for this part, we don't care about what the 9600 is, the 9600 means. So we will only stick to the idea that for it to work, we will need to write it exactly in that way. If you have any question about why is it designed this way, you can ask me during the class or in tutorship sessions. But for now, and to make things easier, we will not care about that part. So in the void loop, I will use my already created variable base temp and assign it a value of 40. So for now, that's everything about that part. Now, this part is a little more tricky, but again, to make things easier and not complicate you or get you confused, I will explain it to you in the simplest way possible. So I will take the Celsius variable and I will assign a temperature value in Celsius. In this case, the Celsius temperature is in this case the Celsius temperature will be first of all will be measured from the temperature sensor. So the temperature sensor is reading a number and we want to convert that number into Celsius. You do that, and to avoid any mistake or problem, what we're gonna do is apply this formula exactly as it is written. So you only have like to copy and paste it, and in the next class, if we have time, I will explain it more detail to translate the numerical measure of the temperature sensor into Celsius. Okay, remember that the map function does some arrangement between the two different ranges of numbers, but for now, remember, we only care about that. You can see this as a formula, and we have to apply the formula exactly as it is in the variable. Now, I already have my temperature translated from temperature sensor into Celsius, and after that, I do the same thing, a formula to translate Celsius to Fahrenheit and store a new value in Fahrenheit. So I have two different variables, Celsius and Fahrenheit. Celsius store the temperature in C and Fahrenheit in F. Now, after that, I will use my serial print to uh, print. I will use serial.print and the variable I want to print. In this case, it will not print the word Celsius. It will print the value that Celsius store. In this other line, when you put quotes, it will print that as a text. So in this case, it will printing the value of Celsius, and in the second line, we'll be printing C straight as a letter as we wrote it. And so we do that again for the Fahrenheit temperature, print the Fahrenheit value, and then print F, exactly as we wrote it between quotes. Now, after that, it's only a bin statement to make the comparison. If the temperature in Celsius is lower than the base temperature, the LED will be turned off. But, or else, that means that when the Celsius is equal or greater than base temperature, then the LED will turn on. Okay, so as you can recall, base temperature is 40. So if Celsius is less than 40, the LED will remain off. But when the LED becomes 40 or more, the LED will turn on. So if we simulate this again, we can go into here. Um, and as you can see here, I'm gonna drag. I'm on 25 now, 33, and in 41, 43, the LED turns on, exactly as our code, as in our code. So this is for the temperature sensor explanation. If you have any other doubt, please let me know either in the class, in tutorship sessions, or via email. I hope you find this useful. And for the homework, what you will have to do is to change the base temperature. In this case, the instructions will be on Canvas, and you can follow them to submit the class evidence for today. That will be due before the end of the day or midnight. Thanks and enjoy the day.